Hi everyone. So this was the third problem of today's lead code weekly contest, and we are going to discuss how to approach this problem today. So first, let's just understand what was given in the problem. So in the problem, we were given an array of integer. So the array will consist only the powers of two. So what are the power of two? Suppose 1, 2, 4, 8, 16, this type of number. What are they? They are 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. That means that all the numbers that are in the array will be a power of 2. So this will be in the array. And what you will be given? You will be given a target. So the target will be anything. Suppose the target is, let's say, 9. So what is that we need to find? We need to find if we can make target by adding up the element from this array as a subsequence. What does that mean? So suppose I want to create 9. So I can take 1 from here and 8 from here. And this two subsequence will be adding up to create 9. So 1 plus 8 will be 9. So in that case, we we need not to make any operation, and we can simply return that without making any operation we are getting the target. What is the operation? I am telling you. So suppose this was 9, this was already there, but suppose we need to find a number. Let's say, what could be the number? There are every number, that's why it is like that. So suppose there is not 16, and suppose there is 32. 32 is also 8 to the power, like 2 to the power 5 is 32. So 32 can be there. So suppose we need to make a target equal to, let's say, 20. So how can we make the target 20? That is the question. How can we make the target 20? So we can add these numbers as a subsequence. So we can take 1, 2 and 32, but they are summing up to 35. So we can do that. What else can we do? We can break a number and divide it by 2 and add two occurrences of that into the end of the array. Let me show you. Suppose we want to take 32 and the number should be greater than 1. Okay, so we can't take 1 and break it by half and append it to the end. So we can take any number that is greater than 1. Suppose there is 32, and what we can do, we can remove it from the array, and we can take, okay, 32 by 2 equal to 16, so we can add two occurrences of 16 here, and this total thing will be one operation. So our operation will be now equal to 1. So in one operation we are breaking 32 and adding two occurrences of 16 in the array. So now what can we do? We can find, okay, so now 16 and 4 will be equal to 20. So that's how we can find the target in one operation. But how can we find that, okay, 20 will be there? So we can make 20 just by breaking 32. There can be many numbers, suppose 32, 64, 128. So how can we say that, okay, we can make 20 by getting 16 from here? How can we say that? So that's where bit mask comes in. So what can be done using the bit mask? So if you see the binary representation of 20, it will be nothing but what is 20? 20 is 16 for plus 4, right? So binary representation of 20 will be nothing but uh, 0, 1, 2, 4, 8, 16. So 10100. This will be the binary representation of 20. So from the binary representation we can see that we need 16 and we need 4. These are the powers of 2. These are the numbers that are power of 2. So 16 is also a power of 2 and 4 is also a power of 2. So these two numbers, if they are present in the array, then we can somehow manage to add them up and create a number 20. So this was the intuition behind it. So how can we approach this problem using this intuition? Let's see. So what can we do? Suppose we had a number, instead of 32 we had, let's say, 64, that is double of 32, and that is 2 to the power 6. As it is 2 to the power 6, so it can be in the array. And suppose we need to break 64 to somehow get 16 and add that to 4 to get 20. So how can we do that? So for doing that, we will be checking, okay, 16 is not there, but we need 16. So what we need, we will be storing that in a map or array or anything else. So for making target equal to 20, what we need 16 and we need 4. That will be adding to a array or map, okay, or set, anything you like, because all the occurrences will be one time, because the bits are unique. Like at every position the value of that corresponding bit will be different. So suppose at index 0, if we have 0, if we have 1, then that would be 2, and for the next one will be 4. This one will be 2, this one will be 4, 8. That's how we can also use a set. So you can do anything you like. So after that we'll check that, okay, if 16 is not there, but we need 16, right? Because in the bitwise representation we are getting 16, but 16 is not there. So how can we do that? We'll be checking, okay, is 2 into 16 there? 2 into 16? No, 2 into 16 is also not there. Okay, what about 4 into 16? Is 4 into 16 there? Yes, 4 into 16 is equal to 64, and that is there. So 4 into 16 is there. Okay, so if we would have found 32, that is 2 into 16, then our operation should be at 1. But as we have found by multiplying 4, so our operation will be nothing but that number, suppose that is k divided by 2. K divided by 2? No, the step number. Suppose in the kth step we have found that number, so our operation will be nothing but k. So if in the kth step we have found the bit, we have found the number that can be broken down to the number that we need, that is 16 in our case. So that is the number of operation that we need to get the number 16. Okay, I hope this part is clear. So okay, let us take a new example. There is an edge case and we will be discussing that. We also need to find the minimum number of operation, right? that is given in the problem statement. So the operation number should be minimum. What do you mean by that? Okay, let's take an example. Suppose the array is like this: 1 1 2 uh, 1 1 2 and what 16 32. Okay, and now our target is, let's say our target is 20. Yeah, why not 20? Because we have already calculated for 20 like what will be the bits. So for 20 we need two number, we need 16 and 4. How we are getting this two number? By looking at the binary representation. So 20's binary representation is nothing but 1 2 4 8 16. So just by looking at the binary representation, we are getting that okay, this at this places the bits are 1, so we need to find this two number that are power of 2. Okay, so 16 is already there, so we don't need to bother about 16. But is 4 there? No, 4 is not there. So how can we make 4? You will be saying, okay, let's check by doing that operation that we have learned. So we will be checking 2 into 4. 8 is there? No, 8 is not there. So at that time k equal to 1. So 4 into 4 is 16 there? No, 16 is also not. Okay, 16 is there. But if we break 16, then we need to again make 16. So we can either take this one or move to the next one. So it's better to move to the next one. So k equal to 2. Now we will be checking, okay, is 32 there? That means 8 into 4 there. We'll be saying, okay, 32 is there. So let's just break 32 and create 216. Okay, I think, yeah, let's just do that. This example is a little bit hard to understand though. So now as we have broken down 16, so in one step we can break 32 to 16, and in again one step we'll break in 16 to 8 and then 8 to 4. So 16 to 8 and then 1 8 to 4. So the array will look something like this: 16 8 and 4. And we have done this in 3 operation. Okay, but what else we would have done to minimize the operation? So see, we need to find the subsequence that can be added to create the target, that is 20. Okay, so 16 we need 16. Okay, and 16 is already there. But 4, can we make the sum equal to 20 by anyhow adding 4 from anywhere else? Right. So 4 can be made by adding these 3 elements. So we can say that okay, don't break 32. Let's just keep it as it is. We don't need to increase our operation. So 32 was there, but let's just see there, like we need a subsequence that can be sum up to the target. So if we take this 4 number, these are also subsequence. So 1 1 2 and 16, so they can be added to create a target, that is 20. Okay, so for doing that we are not making any operation. This was the initial array and this is all, this is as it is. Okay, so how can we check that okay, these numbers were already there, don't break them, they will be requiring us to make the target 4. They are going to like we will be needing them. How can we say that? Okay, So while finding 4, instead of going upwards, like instead of finding 8, 16, 32, as we were finding by increasing k and k, 64, before doing that, if we can see that, okay, can I sum up some values to make 4? How can I do that? Okay, so for 4, before doing this operation, can I check that, okay, is 4 by 2 there? If yes, and that is not needed in there, or there is extra 2 that is there. So if there is any extra number, then suppose we are adding that to our sum. So sum will be 2 because there is a 4, and we will be again breaking down 4 by 4. Is there any extra one? Okay, there is 2 extra one, so we'll be adding those two. And suppose we are able to find the sum equal to this number, sum equal to 4, then we need not to uh, like see that, okay, is if there is a multiple of 4 or not. Okay, so we don't have to do that. And that's how we can minimize the operation. And I hope that this was all for this problem. I'll be adding the code that I have written during the contest. Please go through it if you are not able to understand what I just said. I hope you will be liking this video. Thanks a lot. Bye. See you in the next video.